One of the best things that happened so far is having the right knowledge and understanding of digital logic design. They may not be enough yet, so to better understand the study in this course, let us watch the second part of Logicgates Fundamentals. Hello everyone, I'm Jeffrey Antonico Diaz, and you're watching The Significance of Old School Technology. So before we start, let's talk about what is digital signal. Digital signals are discrete or discontinuous signals whose various states are discrete intervals apart. The typical digital signal in digital electronics is a binary signal, which is defined as a voltage or current that carries information in the form of changes between two different states that are a discrete interval apart. One of these states is called the logic 0 state, and the other, the logic 1 state. For voltage signals, the logic 0 state is typically at ground potential, whereas the logic 1 state varies between positive 3 and positive 5 volts. For current signals, the logic 0 state is typically 0 milliampere, whereas the logic 1 state is 20 milliamperes. What operations can be performed on a single digital signal? A digital device converts an input signal into an output digital signal. The input signal can be assumed to be a train of clock pulses. The question now becomes, what happens to this train of clock pulses through different digital devices? This can be answered in tabular form of listing. The operation that the digital device performs on the input digital signal. In this case, a train of clock pulses. The digital device that is used to perform this operation. The schematic symbol for this digital device. Here, we're going to use Logisim version 2.7.1 to create the remaining logic gates. Thanks for this one-of-a-kind application software is specifically designed for digital logic design developed by Dr. Carl Birch. To better understand how to use Logisim, let us try looking at some of the most commonly used keyboard functions. But before that, let's talk about Boolean expression and truth table. A Boolean expression, named after mathematician George Boole, is an expression used in programming languages that produces a Boolean value that evaluates to either true or false. A Boolean equation is expressed in a way similar to mathematical equation. A truth table is a mathematical table used in logic, most specifically in connection with Boolean algebra, Boolean functions, and propositional calculus, which sets out the functional values of logical expressions on each of their functional arguments, that is, for each combination of values taken by their logical variables. Here's an example of one input, one output truth table. Here's an example of two inputs, one output truth table. It actually depends on you where you are about to place the variables on the top portion of the truth table. But make sure to place the appropriate value according to a standard form of creating a truth table. A buffer is a basic logic gate that passes its input unchanged to its output. Its behavior is the opposite of a NOT gate. The main purpose of a buffer is to regenerate the input, usually using a strong high and a strong low. A buffer has one input and one output. Its output always equals its input. Buffers are also used to increase the propagation delay of circuits by driving the large capacitive loads. The NAND gate operates as an AND gate followed by a NOT gate. It acts in the manner of the logical operation AND followed by negation. The output is false if both inputs are true, otherwise the output is true. The NOR gate is a combination OR gate followed by an inverter. Its output is true if both inputs are false, otherwise the output is false. The XOR exclusive OR gate acts in the same way as the logical either OR. The output is true if either but not both of the inputs are true. The output is false if both inputs are false or if both inputs are true. Another way of looking at this circuit is to observe that the output is 1 if the inputs are different, but 0 if the inputs are the same. The XNOR, exclusive NOR gate, is a combination XOR gate followed by an inverter. Its output is true if the inputs are the same and false if the inputs are different. We send information through computers using wires that represent ones and zeros. Computers need a way to manipulate those ones and zeros so that they can eventually do more complicated operations like calculating the 50th digit of pi. Computers use logic gates to transform the ones and zeros from input wires. A logic gate accepts inputs and then outputs a result based on their state. Logic gates perform basic logical functions and are the fundamental building blocks of digital integrated circuits. Most logic gates take an input of two binary values and output a single value of 1 or 0. Some circuits may have only a few logic gates, while others, such as microprocessors, may have millions of them. That's all for today. Consider this channel as part of your learning journey. Stay safe, and see you in the next part of this video. May God bless us and have a nice day. Don't forget to subscribe.